Hi everyone, welcome back to the Math Society. So this week we'll be going on to do chapter 12 past paper questions, which is differentiations. So let's get right into it. Okay, so starting with question 1. So it says that a container is a circular cylinder. So we know this is a cylinder, open at one end with a base radius of r centimeter and a height of h. So it's a radius of r, height of h. Volume is 1000 cm cubed, and given that R and H can vary and that the total outer surface area of the container has a minimum value, you need to find the minimum value of the surface area. So firstly, we know that the volume is 1000 cm cubed, so we know the volume formula, which is pi r squared h, and that is equal to 1000 cm cubed, right? So if you want to know h, it's just going to be 1000 by pi r squared. And so to find surface area, we know the surface area of the cylinder, the formula of it, which is pi r squared plus 2 pi r h. So it's going to be pi r squared plus 2 pi, and then it's r, and then h, we know that it's 1000 by pi r squared, so you multiply with 1000 by pi r squared. So then pi and pi can be cancelled out, r squared 1 r, then you'll have pi r squared plus 2000 by r. So it says to find the minimum value, so we know that we have to do dA by dr, you have differentiate it. So that's going to be 2 pi r plus, sorry, not 2 pi r plus, 2 pi r minus 2000 by r squared. So we know that dA by dr is going to equal to 0. So then 2 pi r is going to equal to 2000 by r squared. So we know that if you multiply, r cubed equals to 1000 by pi. R is going to be 10 by pi root 3, and that's going to equal to 6.83 centimeter. And then to find the area, we know that it's pi r squared plus, which is 2000 by pi, by r. So you just substitute, and then you'll get, so we have r, you can just substitute, and you'll get 439.4 cm squared, and that is your area. Okay, so now moving on to question 2. So question 2, it says that the radius r of a circle is increasing at the rate of 5 centimeters, centimeter per second. So we know that it's increasing, which means dr by dt, right? So that's equals to 5. And then we have in terms of pi, you need to find the rate at which the area of the circle is increasing when r is equal to 3. So when r is equal to 3, you need to find dA by dt, right? So that's going to be how much? So if you want to know this, A is going to be equals the area of a circle. So it's a circle, so we know that it's going to be pi r squared. So it means dA by dr is going to equal to 2 pi r. So that's r with a radius of 3, so 2 pi 3, so you'll get 6 pi. And then we want dA by dt, and that is equals to dA by dr multiply dr by dt. So we know that dA by dr is 6 pi, and dr by dt is 5. So that's equal to 30 pi. So it just says that in terms of pi. So it's going to be just 30 pi in terms of pi. So, and then we'll go on to question 3. So question 3 says that the volume V of a sphere of a radius r is given by V equals to 4 by 3 pi r cubed. V equals to 4 by 3 pi r cubed. We know its volume. Radius r increasing at a rate of 0.5 as well. Radius, so it's dr by dt is equal to 0.5 again. And find in terms of pi, the rate of change of the volume of sphere when I is equal to 0.2 by I equal to 0.25. So when I is equal to 0.25, so we know that dV by dr, we differentiate it first, which is 3, that's going to be 4 pi r squared. And then it's just going to be dV by dt. That's equal to dV by dr multiply dr by dt. So that's going to be 4 pi r squared, r of 0.25 squared, right? Multiply with 0.5. So you'll just get pi by 8 cm cubed per second. And that is your answer because it just tells you give it in terms of pi. Okay, so now moving on to 4, which says that given that y equal to x squared minus 1 multiplied with root 5x plus 2, you need to show that dy by dx is equal to ax squared plus bx plus c and 2 root 5x plus 2. So that's a form that you have to give where a, b, and c are integers. So firstly, we are going to give it as u and v. You gotta let x squared minus 1 equals to u, and then v as in v is going to be root 5x plus 2. Or you should just do it like let u equals to x squared minus 1, let b equals to root 5x plus 2. And then we're going to differentiate them. So u is equals to x squared minus 1, right? So u prime is just going to be 2x minus 0. So that's 2x. V is equal to root 5x plus 2. That's half. So that's equals to 5x plus 2, the whole power half, right? So v prime is just going to be half. 5x plus 2 minus half. And that's going to multiply 5. So you're going to get 5 by 2 root 5x plus 2. And then we're going to differentiate, which is dy by dx. So that is going to be u prime v plus v prime u. So u prime 2x multiply v, which is 5x plus 2, the power half. That's plus v prime, which is 5 by 2 root 5x plus 2 multiplied with u, which is x squared minus 1. So we're going to multiply them. Well, you get half, so that's going to be like 4x with 5x plus 2 divided by 2 or root 5x plus 2. And then you plus it with 5. That's going to be x squared minus 1 by 2 root 5x plus 2. So then you're going to multiply them. So which you'll get 20x squared plus 8x plus 5x squared minus 5. And the denominator is the same, which is root 5x plus 2. And that's just if you plus them, 25x squared plus 8x minus 5 divided by 2 root 5x plus 2. And this is your dy by dx. Yep, so you've got ax squared plus bx plus c, so it's in that form, so we're okay. And then we're going to move on to question B. So question B says to find the coordinates of the stationary point of the curve for x greater than 0. So you have to give each coordinate according to two significant figures. So we know that dy by dx was equals to 25x squared. I believe it was plus 8x minus 5. Yeah, plus 8x minus 5 to root of 5x plus 2. So then we're just going to have it as 25x squared plus 8x minus 5. That's equals to 0. And we know we can't do the cross method, so we're going to use the formula minus b plus or minus square root of b squared minus 4ac divided by 2a. So that's minus b, which is going to be minus 8 plus or minus a squared. 64 plus 4, 2500, 500 divided by 2a, 2 and 25, that's equal to 50. So you have minus 8 plus or minus square root of 564 divided by 50. So that's going to be minus 8 plus or minus 2 root 141 by 50. So you divide them, you get minus 4 plus root 141 by 50. Oh, sorry, by 25. Or minus 4 minus root 141 by 25, sorry. So that's going to equals, I believe they asked us you're given two significant figures. Yeah, you need to see the questions if they ask you specifically in significant figures. So it's just going to be 0.31 or it's just going to be minus 0.63. And we know that we can't take the minus, so we're just going to reject them. And then we're going to find this is x, you need y. So you're going to just substitute them, which is just going to be minus 1.70. So you get your x and your y. So that's just significance Those are your stationary point. And you have to determine the nature of the stationary point. It means we've got to further differentiate it, which means we have dy by dx. Our dx was 25x squared plus 8x minus 5. And that was divided by 2 root 5x plus 2. So again, we'll have u equals to 25x squared plus 8x minus 5. So u prime is going to be 50x plus 8. Phi equals to 2 root 5x plus 2. And that is actually 5x plus 2, the whole power half. Phi prime is just going to be 5x plus 2 over minus half. That's multiplied by 5. So we know it's going to be d squared y by dx squared. That's u prime v minus v prime u divided by v squared. V prime, 50x plus 8. V, 2 root 5x plus 2 minus v prime, which is 5. And then that's 5x plus 2 minus half. And with u, which is 25x squared plus 8x minus 5. And then divided by v squared, which is going to be 2 squared, so that's 4. 4, and then you just multiply, so it's 4, 5x plus 2, isn't it? After that, we know that x was equals to, x was equal to 0.31, yeah? So x is equal to 0.31. We're going to substitute it in this whole equation, where you'll get 6.26, and that's greater than 0, so we know that, therefore, it is a minimum point. Yep. Okay, so now moving on to question 5. It's given that y equal to x, root x plus 2, show that dy by dx in this format, a and b are constant. So we know that it's following the same format. So we're going to have let u equals to x, and then v equals to root x plus 2. U is equal to x, u prime, that's just going to 1. V equals to x plus 2, the whole power half. So v prime is just going to be half. X plus 2 minus half. So we know that to get differentiated, u prime v plus v prime u, and that's just going to be u, which is x plus 2. U prime is just 1, so we're just going to leave it out. Half x plus 2 minus half, u is just going to be x. So then it's going to be root x plus 2. That's x by 2 root x plus 2. So that's just, plus just right here. So you just multiply them. 2x plus 4 plus x. You'll get 2 root x plus 2. And that's just going to be 3x plus 4 divided by 2 root x plus 2. Yep, so we've got this. And then going to B, it says to find the exact coordinates again. So we know that y prime plus 3x plus 4 by 2 root x plus 2. 3x plus 4 by 2 root x plus 2. So we know the stationary point of a curve. Yeah, so we know that's just going to be 3x plus 4 by 2 root x plus 4. That's equal 0. We know that 3x plus 4 is just going to equal 0. X is just going to equal minus 4 by 3. So y, you're just going to put it there. But it's going to be y minus 4 by 3 root of minus 4 by 3 plus 2. That's equal to minus 4 root 6 by 9. So you're going to have the coordinate as in minus 4 by 3, comma minus 4 root 6 by 9. And those are your coordinates. And C tells you to determine the nature again. So we know that y prime is equal to 3x plus 4 to root x plus 3. So we know u is going to equal 3x plus 4 again. But I'll leave it as 3. And then v is equal to 2 root x plus 2. So that's 2. X plus 2, the whole power half, isn't it? So you'll have v prime as x plus 2 minus half, because half and half will cancel out each other. So you have y double prime again. You can write it as dy by dx as well. D squared y by d squared as well is the same thing. U prime v plus, I'm sorry, this has to be minus u, minus v prime u divided by v squared. So that's u prime v, which is 3, and then v, which was 2, x plus 2 half. And that's going to minus go to v prime, which is x plus 2 minus half. And u was 3x plus 4, isn't it? By v squared, which is, yeah, so 2 squared would be 4x plus 2. Yep, and you're just going to substitute x was equals to minus 4 by 3. So you just get y double prime is going to equal 1.84, and that is greater than 0, and therefore it is a minimum point. Okay, so now moving on to question 6, we have that the diagram shows a solid cuboid with height height h, and a rectangular base measuring 4x, yeah? And then 4x by x, and then the volume of the cuboid is 40 cm3. So this gives us the volume as well. Given that x and h can vary and that the surface area of the cuboid is a minimum value, you need to find this value. So we know the volume as well, which is volume is equals to height. So this is going to be in a different way. So it's just going to be 4x by base, width, and height. Yep. So that's going to be 40 cm3, and that's equal to 4x squared h, right? So then h is just going to be equal to 40 divided by 4, so that's 10 by x squared. So that's your h. And we know that for surface area, it's just going to be 8x squared. It's all the squares plus, so it's just going to be plus 2xh plus 8xh. That's just going to be 8x squared plus 10xh. And you know that 8x squared plus 10x, which is 100 by x squared, isn't it? Or which becomes 100 by x only. Divide them. And then we find the surface area differentiation, d by dx. That's just 8 to 16x plus 100 by x squared. But yeah, this one has to be minus. Yeah, and then we know that 16x minus 100 by x squared, we're going to equal this to 0. 16x is going to 100 by x squared. So you multiply 16x cubed equals to 100. So x cubed is just going to be 100 by 16. And which we know that x cubed equals to 25 by 4. And x is just going to be, you root them, so you'll get 1.84. And we want the area, which is a is equal to ax squared plus 100 by x. And you just substitute the x in there, which is 1.84 squared plus 100 by 1.84, which you would just get 81.4 cm squared, and that is your surface area. Okay, so now moving on to question 7. It says that the volume V of a cone of height h and base radius r is given v equal to 1 by 3 pi r squared h. And then we see that the diagram has a large hollow cone from which a smaller cone of height 180 and base radius 90 has been removed, and remainder has been fitted with a circular base of radius 90 to form a container for water. And the depth of the water is W, and the surface of the water is a circular of radius R. And we have to find an expression R in terms of W and show that the volume V of the water is given by V equal to pi by 12 bracket W plus 180 the whole cube minus 4,048 48630 pi's. Okay. Okay, so now we're going to just find volume of water. So we know that we're just going to have to minus from the bigger one to the smaller one. And we know that the volume is 1 by 3 pi r squared h. So first pi r squared, and then h, we know that it's going to be w and then 180 because it's the bigger one. And we know that r squared is just going to be, you can change it to a bigger r because it's going to be radius r. And minus, we do know the small one was 1/3 pi, r was 90, which is square, and then the height was 180. So then you'll get 1/3 pi r squared. Well, we'll just change it w plus 180 because when you change w plus 180 and minus, you'll get 4x6,123 pi. So we've got the second part shown, but we've got to make sure that this one's shown. So we're going to have it as 90 by r, and we're going to use the similarity. So we have 180 by w plus 180, right? And you're going to have r is going to equal w plus 180 divided by 2. So then volume of water is now going to be 1/3 pi. That's w plus 180 by 2, the whole square. That's w plus 180 minus 4a6,000 pi. That's going to be 1/3 pi. We're going to simplify it. 1 plus w plus 180, the whole square divided by 4. It's going to be w plus 180 minus 4a6,000 pi. So by 4, so you'll get pi by 12. And you have w plus 180, the whole cube, minus 4x6,000 pi. And that is now shown. Okay. And then we move on to B, where it says that point to continuous rate. We know the rate, which is dv by dt, isn't it? And that's equal to 1, 2, 3, 4 cm cubed per second. And find the rate at which the depth of water is increasing when w is equal to 10. So we want to know when w is equal to 10. So we still need to know dw by dt, isn't it? So then v was equals to 5/12 w plus 180 cubed minus 4x6,000 pi. And then you have dv by dw, that's going to be pi by 4. You're going to have w plus 180, which is 4. And that's just going to be pi by 4 multiply 190 squared, because w is going to be 10, so you have 190. And you have 9025 pi. And we want dw by dt, isn't it? So that's going to be dw by dv multiply dv by dt. So that's dw by dv is going to equals 1/9025. So we're just going to flip it around. That's multiply 1, 2, 3, 4. Which you will then get 0.353. So this is the rate at which the water would be increasing when w is equal to 10. Okay, so now we have number 8, which will carve as the equation y is equal to 2x minus 1 root 4x plus 3. So we're going to have it as let v equals to 2x minus 1. Oh wait, we'll start with u. U equals to 2x minus 1. So you're going to have u prime equal to 2. V equal to 4x plus 3, the whole half. That's v prime equals to half, 4x plus 3 minus half, and that's multiplied by 4. And that's going to be 2, 4x minus 3, and that's minus half, right? So then we're going to have dy by dx, which is going to u prime v plus v prime u. So u prime 2, v was 4x plus 3 power half. V prime was 2, 4x minus 3 minus half. And you multiply it with 2x minus 1, which is u. So that you'll get 2 root 4x plus 3 plus, you're going to have 2x minus 1 by root 4x minus 3. I'm sorry, 4x plus 3. So it has to be 4x plus 3. And equals to 2, 4x plus 3 plus 4x minus 2 divided by root 4x plus 3, which you multiply, you get 8x plus 6 plus 4x minus 2 by root 4x plus 3. And that's going to equal to 12x plus 4 divided by root 4x plus 3. And that's just going to be 3x plus 1 by root 4x plus 3. Yep, and b, this is right on the x coordinate, so it's just going to be dy by dx. 4, 3x minus 1, root 4x plus 3, right? We just know that 3x minus 1 is just going to equal 0. Because if you move it, it's still 0. 0, x equals to minus 1 by. Oh wait, it's also 3x plus 1. Yeah, so it has to be minus 1 by 3. And then you have to determine the nature, which is you're going to have dy by dx, which is equals to 3, 4, 12x plus 4 by root 4x plus 3. So you're going to have u equals to 12x plus 4 again. U prime is going to equal 12. Phi equal to 4x plus 3. That's going to be half. Phi prime is just going to be 2, 4x plus 3 minus half. And then you're going to have d square y by dx squared. So that's u prime v minus v prime u by phi squared. U prime 12, v is 4x plus 3 whole power half minus v prime 2, 4x plus 3 minus half. And then you have 12x plus 4. That all divided by v squared, which is 4x plus 3. There you go. And then when x was equals to minus 1 by 3, d squared y by dx squared was, you just substitute, you get 9.03. That's greater than 0, so therefore we know that it is a minimum point. Okay, so question 9, we have that the equation is y equal to x root 16 minus x squared for 0, so x between 0 and 4. Find the exact coordinates of the stationary point. We're going to find the stationary point. So first of all, we're going to have let u equals to x, v equals to root 16 minus x squared. U is equal to x, so u prime is going to be 1, v equal to 16 minus x squared, the whole half, isn't it? So you're going to have v prime half 2x minus 2x, 16 minus x squared. You have minus half, so that's going to equal to minus x, 16 minus x squared, minus half. And we know that dy by dx is equal to u prime v plus v prime u. U prime 1, v is just 16 minus x squared, the whole about half, plus v prime minus x, 16 minus x squared, minus half, u, which was x. So you're going to have 16 minus x squared, half, minus x squared, 16 minus x squared, minus half. So that's going to be 16 minus x squared, minus x squared, by 16 minus x squared, the whole power half, because we move it down. And you have minus 2x squared, plus 16, by 16 minus x squared, half. So then we know we want to find a stationary point, which means we're going to equal it to 0. C by 16 minus x squared, the whole power half, that's equal 0. I have minus 2x squared plus 16 is equal to 0. Minus 2x squared equals to minus 16, x squared, 8. X equals to 2 root 2. Then you're just going to put it in y. Y was x root 16 minus x squared. So that's just going to be 2 root 2. So you're going to put it, you'll get 8. So the coordinate, therefore, is just going to be 2 root 2, 8. And that is your coordinates for the stationary point. Okay, so we now have question 10. So it says that the rectangle ABCDE represents a plot field where AB is equal to 300 meter and then A is equal to 400. So this one's 300, 400. So if you want CD, that's 400 minus X. And it says Joseph needs to walk from A to D in the least possible time. So he can walk at 0.9 meters second on the plot phi. So he can walk 0.9 if he's on the plot phi. And 1.5 on any part of the plots BCD along the edge of the field. So he can he can walk at 1.5 meter per second. And C to D, distance BX is equal to X. So yeah, we know that it's X. So we're gonna find in terms of X the total time T that Joseph takes for the journey. So firstly, we need to find this first because we know the distance where he can walk. So it's going to be AC squared equals to, which is 300 squared plus X squared, isn't it? 90,000. 4 zeros, yes, plus X squared. Then you want AC, which is going to be root of 90,000 plus X squared. So now we know that this one is 90,000 plus X squared. And so what time, which is time is equal to distance by speed. So time, distance, we know it's 90,000 plus X squared by speed, which was 0.9, yes. And then we want to find this other thing where it's just he's going to walk. He knows that we can only here he can walk 1.5 meter per second, right? So it's going to be 400 minus X divided by 1.5. Because we need to find from A to D where he'll be walking from A to C and C to D. So we need 400 by X divided by 1.5 as well. So that's going to be the total time T that he's going to take for this journey. And we'll move on to given that X can vary, find the value of X for which T is a minimum, and hence find the minimum value of T. So we know that T was equals to square root of 90,000 plus X squared divided by 0.9 plus 400 minus X divided by 1.5. So that's going to be dt by dx. So that's 1 by 2 multiply 0.9 multiplies 90,000 plus X squared. That's going to be equals minus 1 by 2 multiply 2X minus 1 by 1.5. So that's 2. 2 going to cancel out each other. So you're going to have 0, 1 by 0.9 multiply X, 90,000 plus X squared. You have minus half minus 1 by 1.5. So 1 by 1.5, that's going to equal X by 0.9 multiply with 90,000 plus X squared minus half. You're going to have 3 by 5 equals to X. 90,000 plus X squared minus half. So then you're going to have 90,000 plus X squared minus half equals to 5X by 3. If we move it there, we have 90,000 plus X squared equals to 25 by 9X squared. So then you'll have 90,000 equals to 16 by 9 X squared as well, which means X squared is just going to equals to 5,625. So that's going to have X, you root them, you'll have 225. So for T, you want to know of it was 90,000 plus X squared. 225X squared divided by 0.9 plus 400 minus X, which was 225 divided by 1.5. So then you're gonna get a value time of 500, 300.3333. So that's going to be just T value. And here is your T value. And that's going to be it for today's video, and I'll see you back in the next week video.